Okay, so members, now we are going to see reflection in details, and please don't forget to subscribe to the channel. Now, we've seen matrix of transformation, we've seen also enlargement, we have seen translation, now we are handling reflection. So, there are majorly 4 lines in the reflection we are going to focus on. There are lines, but we are going to major on these 4. Now, reflection in matrices deals with identifying objects and their images in a plane mirror. Mirror line is a line where a reflection of an object takes place. So mirror line, this is where the reflection occurs, as simple as that. And they include y equal to 0. If they don't tell you y equal to 0, they will tell you the x-axis. They will tell you that a matrix, an object, this is reflected in the y-axis. In the x-axis, it means that you need to know which line are they talking about. So y equal to 0 is the same as the x-axis, x equal to 0 is the same as the y-axis, y equal to x, or sometimes now they can put it in this form when they take x to the other side. When they take x to the other side, it becomes a negative. Or, and then y equal to negative x, these are solid lines, these two. They are passing through the origin and they are passing through every value of x is equal to the value of y. Then this one, we take it this side, it becomes now y plus x equal to 0. So if they don't bring it in this format, they bring it in this form. So always be careful. Properties of reflection, these ones are going to be, by the way, properties in the physics also. Object and the image have the same size, so the size doesn't change. Like when you look in the mirror, your size is not changing, it's you. Then point on the mirror line is not reflected. So these points on the mirror lines, they are not reflected, they remain in the rear. So they form their own images. Image distance from the mirror line is equal to the object distance from the mirror line. So an object and this from a mirror line is the same as the distance between those two. Then it will be the same distance between the mirror line and then the image. Line joining the image and its object is perpendicular to the mirror line. Of course, those two, if you join them, that line that is joining the image and the object, it should be perpendicular at 90 degrees with the mirror line. General matrices of reflection, we use the n square. N square has matrices O, I, J, and K. These are the coordinates. Let us see how we generate this mirror and matrices of reflection. So for x equal to 0 is going to be our first major line. For x equal to 0, we say is the same as the y-axis. Now this is the major line. So this is our line. Now the y-axis, all of you know what the y-axis is. This is the y-axis. Now we want to see what are reflected. We say now at this point here, the J is on the mirror line. And we say points on the mirror line are not reflected. So it means that this one is going to form its own image. It's the image of itself. While this one, now look at I. When I look at I, if I put here, this I is going to be reflected this side. So this I is going to move from here and then it goes here. Like that. Because if this is the same distance, even this one is going to be the same distance. So from here up here is 1 and from here up here is 1. So this is where I'm going to form the I line, the image. This is going to be the object and then its image. So now our matrix M is going to be now we plot the coordinates of those images. Now the image for I is, remember this coordinate is going to be negative 1, 0. So here it's going to be negative 1, 0. This coordinate here. So it's negative 1, 0. Then J, remember I said this is on the mirror, so it's going to reflect them. So its image is going to be the same. So it's at 0, 1, and that is our matrix of reflection there. When I come now to y equal to 0 is the x-axis. Now this is the mirror line. So y equal to 0 is the x-axis. Now what are you going to reflect? You see that now I is on the mirror line, so it's not going to be reflected. While this J is going to be reflected to the opposite side, this side, so it's going to be reflected here, like this. So here we are going to have now j prime. The coordinates are going to be x is 0, then negative 1. So now our matrix there, which is going to be the image of I and the image of j. Image of I, remember I is not shifting because it's on the midline. So it's going to remain as 1, 0. Then our j, remember it's different from here to here. So its image is as 0, negative 1. As simple as that. Now when you come to this one is being a little bit careful. These ones are very easy. But this one, be careful. Now, y equal to x or y minus x is equal to 0. It's a line that passes through the origin and 1, 1, 2, 2, and so on. This is the line, its nature. Now, it means that if I put this line here, this one is going to be reflected here. And then this I is going to be reflected here. So it means that now, this j here is going to come here. This j is going to be reflected here. Then this I is going to be reflected there. This I is going to be reflected there. So that's the only thing. This one is going to be here. It's going to be now reflected here. So here we are going to have now our j prime, the image. Then this I is going to go here. So we are going to be having I prime there. Why? If you are here, the perpendicular distance here is that this one is going to go direct there, and then this one is going to come here. As simple as that. So now the coordinates are going to be, now our coordinates for the I prime and the j prime are, first of all, our I prime is here. Now the coordinates here is going to be 0, 1. So it's at 0, 1. Then the j prime, now it's shifted from here to here, meaning that this is the new place for the j, which is 1, 0. As simple as that. So that is our matrix of reflection in y equal to x. Now when I come to this one is still be careful. Now this is how we put this line. It's negative gradient, that's why it's passing like that, passing from the origin. So it's that this j is going to be reflected here. This j is going to be reflected there. So we are going to be having our j prime there. What about I? You see that I is going to be reflected here, there. So we are going to be having our I prime there. As simple as that. This is reflected here, and this is going to be from here up to here. As simple as that. Here, they were just extending. But here, this one comes here, and this comes here. So now I'm going to find matrix of, now the image of I and j. I is that now, this coordinate here is 0, negative 1. Then this coordinate here is going to be negative 1, 0. So 0, negative 1. Then this one is for j, is negative 1, 0. As simple as that, and you are finished. So that's how we did it to those matrices, the parts. So meaning when x is equal to 0, the matrix here, when x is equal to 0, the matrix here is negative 1, 0, 0, 1 with is. When y is equal to 0, our matrix is going to be 1, 0, 0, negative 1 with is. For y equal to x, our m is going to be 0, 1, 1, 0. Then for y, our matrix is going to be 0, negative 1, negative 1, 0 with is. Those will be our matrices of reflection. So now members, whenever I tell you that a triangle this was reflected in the y equal to x, this is going to be the matrix. In simple terms, they will be giving you the matrix of reflection indirectly. If you don't know how to generate them, maybe if you are forgetting, this is the way we have applied. Use the way we have applied them. I wish you will. We are going to see now examples.